Hello everyone, welcome to Math Archives. Today I am going to explain two-way classification of ANOVA. In two-way classification, we have to take two factors, one along the column wise and the other one along row wise. Whereas in one-way classification, we have to take only one factor, that is either along the column wise or row wise based on the requirement of the given problem. Now I am going to explain two-way classification of ANOVA in detail. For that, let me take a simple example and explain the procedure involved in two-way ANOVA. So, perform two-way ANOVA for this problem. Here plots of land and treatment is given. There are three different plots is given, 1, 2, 3 and 4 treatments is given here, A, B, C, D, that is named as A, B, C, D, and these are all the values. Now we have to perform two-way ANOVA for this problem. So, for that, let us first set up null hypothesis, alternative hypothesis for this problem first. So, null hypothesis generally denoted as H0. Here, we have to set up two null hypotheses. One is for column and another one is for row. So, for the first one, I have to set up the null hypothesis for along column wise. That is, there is no significant difference. There is no significant difference between, in column we have treatments, so there is no significant difference between treatments. Treatment here represents column wise, whereas the second one I have to set up the null hypothesis along row wise. Here there is no significant difference between row, that is plot of rank, between the plots of land. Here this is for row wise. So we have to set up null hypothesis for two factors. One is along the column and the other one is along row wise. So alternatively, we have to set up the alternative hypothesis. Usually it is denoted as H1. As usual for null hypothesis, here itself we have to set up the alternative hypothesis for row and column separately. So for the first one, we have to set up it for column wise. That is, there is no significant difference between treatments, that is as a null hypothesis. For it, there is an alternative hypothesis. There is a significant difference between treatments. For the second one, this is for row wise. So, I have to set up the alternative hypothesis for plots of land as there is a significant difference between, here plots of land, between the plots of land. So nothing is mentioned about the level of significance. So by default we have to take alpha as 5% level of significance, that is 0.05. So we have set up the null hypothesis and alternative hypothesis and level of significance. Let's move on to the calculation procedure. For that, let me first construct a table and we calculate these values, that is n, t, t square by n, that is a correction factor, and TSS, total sum of square, and SSC, sum of squares between columns, and SSR, sum of squares between rows, and SSCE, sum of squares due to errors. So, before we are going to find out the calculation values for these, Let us now look at the values given in our problem. These seems to be something large. So if you square these values, you get the values in terms of 1000, that seems to be very tedious to calculate the values and adding the values like that. So for that I am going to use the coding method. So the coding method is nothing but I am just pick a value and subtract that value from all these numbers, so that it reduces the large number to a very small number. So our calculation seems to be very simple by using this coding method. And also the resulting value of f is a ratio value. So by doing this type of coding method doesn't affect the value of f. That is, coding means we have to either add, subtract or divide any value from all this. So that doesn't affect the value of f ratio. So I am going to use the coding method here in order to reduce this large numbers to a small one. How I am going to pick that value from these values? Arbitrarily you have to take any value. So I have to take it by doing a simple calculation. I just want to show you that. So I am just show you how I am going to take the value from these values to reduce it to a small number. For that, let me add all these values. So let's start with 38. 38 plus 45 plus 40 plus 40 plus 42 plus 38 plus 41 plus 49 plus 42 plus 39 plus 36 plus 42. You get the total as 492. And you divide this by the number of values given here. So totally we have 3, 6, 9, 12 and divide this by 12. You get the value exactly 41. I am going to take this value as a whole number. That's something near to round off number, that is 40. So I just subtract 40 from all these values. Listen carefully. I am going to subtract 40 from all these values. So if you are going to subtract 40 from all these values, that is 38 minus 40, 45 minus 40, 40 minus 40 minus 40, like that. So you are going to subtract 40 from all these values. So it reduces to resulting value should be a small number, isn't it? So 38 minus 40 is minus 2, 45 minus 40, that is 5, 40 minus 40, that is 0, and for the second column 40 minus 40 is 0, 42 minus 42 and 38 minus 40 you have minus 2, and for the third column 41 minus 41, 49 minus 40 is 9, 42 minus 42, and for the last column 39 minus 40 minus 1, 36 minus 40 minus 4 and 42 minus 42. So look at these values. So using coding method, my calculation part becomes very simple, isn't it? So by using this type of coding method doesn't affect the value of S ratio. So I have to reduce this large number to a small one by using this coding method by subtracting 40 from all the given set of values. Now let me move on to the next part of our calculation. So now let me construct a table and write down the values here. After reducing using coding method, I have to write down all these values here. Now what I am going to do next is I am just going to assign the variables for this. So as a column wise, I have to assign x1 for the first column, x2 for the second column, x3 for the third column and x4 for the fourth column. So for treatments, I have to assign the variable as x1, x2, x3 and x4. Likewise for plots of land, I have to assign some other variable as y1. y1 for the first row, y2 for the second row and y3 for the third row. So after assigning the variable, our first step is let us write down the value of n. n is nothing but the total number of observation given in our problem. So totally we have 1, 2, 3, 3, 6, 9, 12. So there are totally 12 values, that is 12 observations are given. So n is equal to 12 here. And t is nothing but the grand total that we are going to calculate now. So for that, let me calculate row total and column total now. This row total is nothing but sigma y1. Sigma y1 is minus 2 plus 0 plus 1 minus 1. We get the total as minus 2. And for the second row, that is sigma y2. By adding 5 plus 2 plus 9 plus minus 4, we have 12. And sigma y3, that is sum of all values of y3, that is 0, minus 2 plus 2 and plus 2. We get the total as plus 2. So after adding all these values row wise, let me calculate this total along its column, that is sigma x1, that is minus 2 plus 5 plus 0, that is 3. Next sigma x2, 0 plus 2 minus 2, I get the value 0. Resulting value for the second variable x2 is 0. Next for sigma x3, that is 9 plus 1 10 plus 2 12. And for sigma x4, minus 1 minus 4, that is minus 5 plus 2, that is minus 3. And T here is the total of all these values. By adding all these values along its column wise and row wise, we get the value of T. So let me add this along column wise. 3 plus 0, 3 plus 12, 15 minus 3, that is 12. Along row wise, minus 2 plus 12 plus 2, that is 12 itself. So here T is equal to 12. So our calculation value of T is 12. Next I am going to calculate the correction factor, that is T square by n. The value of T is 12, that is 12 square over n value is 12. That is, you get the value of correction factor T square by n as 12 square, one of the 12 being cancelled. So you get the resulting value of the correction factor as 12 itself. Now let me move on to the next calculation part, that is TSS. TSS is nothing but total sum of square. This is calculated by using the formula sigma x1 square plus sigma x2 square plus sigma x3 square plus sigma x4 square minus the correction factor T square by n. So you know all these values already, means you calculate this value of TSS, but before calculating this we need to know the value of sigma, that is sum of the values of x1 square, x2 square, x3 square and x4 square. So for that, let me first calculate x1 square, x2 square, x3 square and x4 square. x1 square is nothing but square of the values of x1, that is minus 2 square is 4 and 5 square is 25 and 0 square is 0. Next x2 square, 0 square is second column, 0, 4 and 4. And for the third column, 1 square 1, 9 square is 81 and 2 square is 4. And for the last column x4, minus 1 square is 1 itself, minus 4 square is plus 16 and 2 square is 4. By adding all these values, you get the total as sigma x1 square and sigma x2 square, sigma x3 square and sigma x4 square. Adding all these values, 4 plus 25 plus 0, you get 29. And 0 plus 4 plus 4, you get 8. 1 plus 81 plus 4, you get the value as 86. And adding all these values, we get sigma x4 square, that is 16 plus 4 20 plus 1 21. Now we calculate total sum of square using all these values, that is equal to sigma x1 square, that is 29 plus x2 square, that is 8 plus x3 square, that is 86 plus x4 square, sigma x4 square, that is 21 minus correction factor 12. By adding all these values, we get the total sum of square. Now by adding 29 plus 8 plus 86 plus 21 minus 12 we get the total as 132. So our TSS, that is total sum of square, is 132. And next we calculate SSC, that is sum of squares between columns. For that we make use of this formula, that is sigma x1 whole square over n1 plus sigma x2 the whole square over n1 plus sigma x3 the whole square over n1 plus sigma x4 the whole square by n1 minus correction factor t square by n. Here n1 represents number of elements in each column. So here n1 represents number of elements in each column, that is under x1 how many number of elements is here, and we just write down the value. Since we are having equal number of values under x1, x2, x3 and x4, so we get the unique values, that is 3 in the denominator of all. So we have to just write down all these values and make a calculation to get the value of SSC. That is sigma x1, that is 3 square over, under x1 we have 1, 2, 3. So we have 3 elements plus sigma x2. Here sigma x2 is 0. So 0 square by, under x2 itself we have 1, 2, 3. So totally we are having 3 elements plus sigma x3. Sigma x3 value is 12. So 12 square by x3 having 3 elements plus x4. Sigma x4 is minus 3. So minus 3 square over 3 minus correction factor t square by n, that is 12. So by simplifying this we get 3 square by 3, that is 3 plus 0. 0 by anything is 0 itself plus 12 square by 3, that is 12 square value is 144. If we divide that by 3 we get 48. So 48 plus minus 3 square by 3 is nothing but 9 by 3. So we get 3 minus 12. So by adding all these values we get 3 plus 0, no need to add 0. 48 plus 3 minus 12, we get the total as 42. So our SSC, that is sum of square between columns, we get the value as 42. So SSC is 42. And next we calculate the value of SSR, that is sum of squares between rows. This is calculated by make use of this formula, that is sigma y1 whole square over n2 plus sigma y2 the whole square over n2 plus sigma y3 the whole square over n2 minus the correction factor t square by n. So you know already the values of sigma y1, y2 and y3. So we just make use of these values, that is sigma y1 is minus 2 the whole square by, here n2 represents number of elements in each row. So in each row we have 1, 2, 3, 4. So totally we have 4 elements, and in y1, in y2 also we have 1, 2, 3, 4 and y3 also we have 1, 2, 3, 4. Since we are having equal number of values given in our problem, so n2 is nothing but number of values in each row. So our n2 is 4 plus sigma y2 is 12. So 12 square over 4 plus sigma y3 is 2, that is 2 square over 4 minus the correction factor value is 12. Now we just make simplify this calculations, that is minus 2 square is 4, 4 by 4 is 1 plus 12 square, that is 144. 144 by 4 gives you the value 36 plus 2 square by 4 is nothing but 4 by 4, 1 minus 12. By adding all these values we get the value of SSR, that is 1 plus 36 plus 1 minus 12, that is equal to 26. So SSR value we have calculated as 26. The last one we calculate SSE, that is sum of squares due to error. That is calculated by make use of the formula TSS minus SSC minus SSR. So already we know all these values. TSS, that is total sum of square, is 132. Minus SSC, that is 42, minus SSR, that is 26. By adding all these values, that is 132 minus 42 minus 26, we get the total as 64. So our SSE is 64. So we calculated all the values that we need to calculate the F ratio for column and also for row 2. So let me now move on to the two-way ANOVA table. This is what our two-way ANOVA table looks like. So whereas here the first column represents source of variation, consists of between columns, between rows, error and total. The second column represents sum of squares, that is SSC, between columns, sum of square between columns, sum of squares between row, and SSE, that is sum of square due to error, and the last value TSS, that is total sum of square. Here the third column represents degrees of freedom. Here C represents number of column given in our problem, and R represents number of rows given in our problem, and for degrees of freedom for error is C minus 1 into R minus 1, and this total could be equal to N minus 1. Next we calculate the mean sum of square. So this column represents MSC, MSR and MSE. These are the values that we have calculated by make use of these two values, and next one we calculate the F ratio by comparing this MSC with MSE and MSR with MSE. That is, we have to compare between column with error and between row with error and make a ratio of F, and finally we have to compare this value with the table value. For that we have to write down the table value of F here. First write down the values that we have calculated so far. SSC first. SSC is sum of squares between columns, that we have calculated as 42, and SSR, that is sum of square between row, that is 26, and SSE, sum of square due to error, that is 64, and TSS is total sum of square, that is 132. Now C minus 1, degrees of freedom for between columns, that is obtained by subtracting 1 from column, that is C minus 1. Number of columns given in our problem is, totally we are having 1, 2, 3, 4 columns, and 1, 2, 3 3 rows. So our C value is 4 and R value is 3. So 4 minus 1, that is 3, R minus 1, that is 3 minus 1, that is 2. And for the C, we just multiply the value of C minus 1 and R minus 1. So 3 multiplied with 2 we get 6. And this total would be equal to N minus 1. Let me check. 6 plus 2, 8 plus 3, 11. Yes. So totally we are having N value is 12. So 12 minus 1, 11. So this total is equal to 11. Now we'll next calculate mean sum of square. So this is calculated by making the ratio of SSC over C minus 1. So MSC is equal to SSC over C minus 1. So the value of SSC is 42 by 3 is equal to 42 by 3, that is 14. Next MSR, by taking the ratio of SSR over R minus 1, we get SSR, that is equal to 26 by 2, that is 13. And MSE by taking the ratio of SSE over C minus 1 into R minus 1, we get the ratio of MSE, that is 64 by 6. So if we divide 64 by 6, we get 10.67, isn't it? So here we have to calculate the two ratios, one for column and the other one for row wise. Let me first calculate the F ratio for columns. FC is, that is, this F ratio is calculated by taking the ratio of MSC and MSE. So look at the two values 14 and 10. Here 14, that is MSC has the greatest value while we comparing with MSE. Since the resulting value of F ratio should be greater than 1, based on that we have to choose the value of F. Based on that we have to choose the numerator value of F. The higher value occupies the numerator and lower value occupies the denominator. So here MSC is 14. So 14 by 10.67. Now 14 by 10.67 gives you the value as 1.31. I have to take up to two decimal places. So 1.31. 1.31. Next FR. So this is calculated by taking the ratio of MSR and MSE. Next we calculate the F ratio for between rows. That is, for that we have to make the ratio of MSR with MSE. Look at the values here now, 13 and 10.67. So MSR having the higher value compared with MSE. So I have to take MSR in the numerator. MSR is 13 over 10.67. That is equal to, by taking the ratio of 13 by 10.67, we get 1.2183, etc. So I have to take here up to two decimal places. So 1.22. So we calculated the F ratio for column and row treatments. You just remember that by taking the F ratio, you just remember that the numerator of the value should be greater than the denominator. Based on that, you have to choose the values, either which one occupies the numerator and which one occupies the denominator. The resulting value, the calculation of resulting value of F should be greater than 1. Based on that, we have to choose the numerator value of F. So which one is the highest value is occupies the numerator, and the second one occupies the denominator value of F. Okay. So based on that, we choose the values, which one occupies the numerator and denominator. Then next, we just compare this value with the table value at 5% level of significance. So FC, that is F ratio at MSC has the degrees of freedom 3. So we have to take 3 in the numerator, and MSE having the degrees of freedom 6. So the value of F at 3,6 degrees of freedom is, likewise FR, the F ratio for R at MSR has the degrees of freedom 2. So we have to take 2 in the numerator, and MSE has the degrees of freedom 6. So we have to take 6 at the denominator. So we just look at the two values from the table and just show you the table. First, let me find out the value of F at 3,6 degrees of freedom. That is, we have to look at the value of 3 in the numerator and 6 at the denominator. So this is what the distribution table at 5% level of significance. For 3,6 we have 4.7571. I have to take up to two decimal places, that is 4.76. And the next, the value of f at 2,6 degrees of freedom. We have to just look at 2 in the numerator and 6 in the denominator of a table. So 2,6, 5.1433. I have to take up to 2 decimal places, so 5.14. Now, after find out the table value, we just compare these two values between rows and also columns. Now, let me compare first calculated value of FC with table value of FC, that is column ratio. This is 1.31 and whereas the table value is 4.76. So the calculated value of F is strictly less than the table value of F. And also for row wise calculated value of F, or I am going to compare this with table value of F. So calculated value here is 1.22 whereas the table value is 5.14. So definitely this value also strictly less than the table value. So in both cases calculated value is less than the table value. So I am going to accept. So we accept H0 in both cases. That means we reject the alternative hypothesis H1. Hope you got a clear idea about two-way classification of ANOVA. Thanks for watching. See you again in my next video.